Hello students, in this session I'll be talking about an excellent shortcut method for finding the products in ozonolysis reaction. Please listen this video up to the end so that you get all the details regarding the ozonolysis reaction. Towards the end of this video, I am giving the trick for finding the ozonolysis product. After watching the video, please don't forget to take down the notes or study material given in this video. Let us first explain what is ozonolysis reaction. Ozonolysis is a very important reaction in organic chemistry. What is the purpose of ozonolysis reaction? It is used for breaking down carbon to carbon double bond in aliphatic and alicyclic alkenes. Whenever we want to break up a carbon to carbon double bond, the first reaction which comes in our mind is ozonolysis reaction. Then how will you carry out an ozonolysis reaction? It is a very simple reaction. What we do is first treating the alkene with ozone to form ozonide. Then ozonide is hydrolyzed with water. So ozonolysis is a two-step reaction. In the first step, we are treating alkene with ozone to form ozonide. So the first step is ozonide formation. Then ozonide formed is treated with water. Then it undergoes hydrolysis. So ozonide formation combined with hydrolysis together known as ozonolysis. We shall explain ozonolysis with the help of an example. Consider ozonolysis of propene. When you treat propene with ozone, what happens is that the three oxygen atoms in ozone adds to this carbon to carbon double bond in a peculiar way. One of the oxygen atoms forms a bridge, carbon to carbon bridge like this. The remaining two oxygen atoms you can see forms a single bond and also join to each carbon atom. The resulting compound is known as ozonide. In this case, alkene is propene, so the ozonide is known as propene ozonide. This is the first step. After that, what we do is treating this ozonide with the water in presence of zinc. Then the bonds will break. What are the bonds going to be broken? First of all, C oxygen bond. This will break. Then right side C oxygen bond will break, and also oxygen to oxygen bond will break. First this bond, then it will be broken, then this will be broken. So this oxygen atom comes out. The oxygen atom you can see at the top, it will react with the zinc to form the byproduct zinc oxide, and we get two main fragments, main products. One is CS3CHO. It is known as ethanol or acetaldehyde. Next one is CH2O, this much part, CH2O. So the first fragment is CH3CHO, ethanol or acetaldehyde. Second fragment is CH2O. CH2O you can write as HCHO, methanol or formaldehyde. So the main products are carbonyl compounds. In this case, both are aldehydes. In some cases, we may get ketone depending on the substitution on these carbon to carbon double bond. Depending on the substitutions, we may get ketone also, right? Now let us explain some important points regarding ozonolysis reactions. First one, ozonolysis. It is a combination of two reactions. In the first step, formation of ozonide. In the second step, hydrolysis of ozonide. Then second point, what about ozonolysis products? Ozonolysis products are carbonyl compounds. The carbonyl compounds may be aldehyde, ketones, or carboxylic acids. The nature of carbonyl compounds, whether aldehydes, ketones, or carboxylic acids, depends upon two important factors. First one is alkyl substituents on double bonded carbon atoms in alkenes. Second factor is type of ozonolysis. Now I shall explain the first factor, alkyl substituents on double bonded carbon atoms, how they affect the nature of carbonyl compounds formed in ozonolysis reactions. Consider the above reaction, propene. Propene on ozonolysis gives ethanol and methanol. Both are aldehydes. Suppose there is a substituent, methyl substituent on second carbon atom. Then the first product may not be ethanol. Instead of ethanol, we get acetone. So the products will be a mixture of ketone and aldehyde. In this way, the substituents on double bonded carbon atom can affect the ozonolysis products, right? Coming to second factor. Second factor is type of ozonolysis. There are two types of ozonolysis, reductive ozonolysis as well as oxidative ozonolysis. If zinc is used, it is known as reductive ozonolysis because it prevents further oxidation of ozonolysis products. In this reaction, propene on ozonolysis gives acetaldehyde and formaldehyde. Since zinc is used, acetaldehyde is not going to be oxidized to acetic acid. Formaldehyde is not further oxidized to formic acid. This is because this oxygen which comes out combines with the zinc to form byproduct zinc oxide. If zinc is absent there, what happens is that this oxygen will oxidize H2O to H2O2, which is acting as an oxidizing agent. H2O2 will oxidize acetaldehyde to acetic acid, formaldehyde to formic acid. Then it becomes oxidative ozonolysis. So if zinc is used, it is known as reductive ozonolysis because it prevents further oxidation of ozonolysis products. If zinc is absent there, what happens is that the aldehyde formed in the ozonolysis reaction may further oxidize to corresponding carboxylic acids. Such type of ozonolysis is known as oxidative ozonolysis, right? Next I am going to explain the shortcut method or trick for finding the ozonolysis product. For entrance examinations, we don't have much time for solving the questions in detailed manner. So we need to have a method, a shortcut method or a trick for finding the correct option. In ozonolysis, the trick which we use is breaking the carbon to carbon double bond and then adding oxygen atom to each fragment. In this case, propene, what we do is, first of all, we are breaking carbon to carbon double bond. Then we get two fragments, left side CH3CH, right side CH2. After that, we are adding oxygen atom to each fragment. So the left side fragment becomes CH3CHO, ethanol. Right side fragment is CH2O, it is nothing but methanol. This is the way you can find out the correct option in seconds time in the case of ozonolysis. Correct? Now I am giving some questions for testing yourself. If you are able to do all these questions, then you will become more confident for facing competitive examinations. First one, methyl prop 1 when it is subjected to ozonolysis, what happens or what are the products obtained? Here we are applying the trick, breaking the double bond here, then attaching oxygen atom to each fragment. So the left side fragment becomes CH3CO, CH3, propanone or acetone. Right side fragment is CH2O, it is nothing but HCHO, methanol. Similarly, we can consider the second compound, cyclopentene. When it is subjected to ozonolysis, what happens? We are breaking the double bond here, then adding oxygen atom to either side. One oxygen atom goes to this carbon atom, another oxygen atom goes to this carbon atom. Due to the breaking of carbon-carbon double bond, the ring gets opened and this end becomes CHO and also this end becomes CHO. The resulting product is pentane diol. Then we can consider another example, cyclohexa 1,3-diene. In this structure, you can see two carbon-carbon double bonds. So on ozonolysis, what happens is that both these double bonds will be broken. It will break, then this double bond also breaks. Then next step we are adding oxygens. Here one oxygen, then another oxygen goes to this carbon atom, then another oxygen goes to this carbon atom. So the ring gets broken, gets opened, then we'll be getting two products. Due to the breaking of ring, we get a fragment like this. This carbon atom is CHO, this one is CHO. So this fragment is butane diol. The next fragment is this one. Here the end carbon atom CHO, this is also CHO. So the product is CHO, oxaldehyde. Then we can take the last example, 2,4-dimethyl hexa 2,4-diene. This one ozonolysis gives what? Here also we are applying the trick. Double bond here breaks, another double bond here breaks, then adding oxygen atom to this carbon, another oxygen atom to this carbon, then another oxygen atom attaches this double bond carbon, another oxygen atom attaches to this double bond carbon. So here we will be getting three types of products. This fragment becomes CH3COCH3, that is acetone or propanone. The middle fraction CHOCOCH3, CHOCOCH3, it is 2-oxopropanol. Then last fraction CH3CHO, CH3CHO, it is acetaldehyde. So by this way we can find out the ozonolysis product in a second's time, right? For more videos of this type, please click on subscribe button. Also give a big like to this video. Make comments and share. Thank you all, my dear students.